All right, we're going to continue the rest of this lesson. We're going to solve logarithmic equations. Okay, so when you have log equations, you're either going to convert it to exponential, or what you can do is use one-to-one property if you have log equals log, or what you're going to do is you're going to condense and either do one of the two that I just mentioned, so one-to-one property or change it to exponential. Might not make a ton of sense in words, but when I do these problems, you're going to kind of get the idea. One big concept here, though, right, let me highlight this, is that log expressions are only defined for positive real numbers. All right, what does that mean? Is that you could have extraneous solutions. All right, so it says it right here, exclude any solutions that would result in finding the log or ln of a negative or zero. So inside of the log, I'm just going to say inside of the log must be positive. Must be positive, right? It cannot be zero or negative. All right. So that's just one thing to keep in mind, is that when you get an answer in a log equation, you want to make sure that when you plug it back in, you get a positive number. All right. So something like this, if I have ln of x equals 3, I only see one singular log here, so what I'm going to do is I'm going to convert it to exponential. So this is the same as log base e of x equals 3. All right. So that should be something that by now we know pretty well, right? ln is the same as log base e. And then what you're going to do is you're going to convert it to exponential. So I get e to the power of 3 is x. All right, and then that is our exact answer, right? Simple as that. What we want to do, though, again, just like the previous lesson, is we want to plug it in to our calculator and then get a decimal approximation, right? So x in this case would approximately, I'll do the same thing, I'll do 3 decimal places, is approximately 20.086. All right, shouldn't be too bad. All right, something like number 14 is the exact same thing, right? If I see ln, I can treat that as log base e of x equals 2, and then you can convert it to exponential. So this is x equals e to the power of 2. Again, that's our exact answer. We can plug this into our calculator and then get a decimal approximation. This should get you 7.389. And then notice when you plug these two answers that we just got back into x, right, we don't get any negative numbers, right? There's just a singular x inside, right? So when you plug it back in, you get a positive number, right? No negatives there, all right? If you look at something like number 15, right, you're probably like, okay, well, I see 2 logs here. How am I going to get that? How am I going to convert it to exponential? All right, you don't need to convert it to exponential, just because what you should notice is that there's the same exact log on both sides. It's a log base 3 and a log base 3. Just like with exponents, if you have the same base in a log, you can simply cross it out, and then you're left with whatever is on the inside. So I get 5x minus 1 equals x plus 7. All right, and then you just solve this like any other linear equation, right? Subtract x, add 1, and then you get 4x equals 8. Divide by 4, and then you get x equals 2. All right, now you want to make sure that when you plug it in, you don't get a negative, right? So if you plug it in here, all right, you get 10 minus 1, which is positive, so it does work. And when you plug it in here, you get 2 plus 7, which is positive 9, so it does work there as well. All right, so that means 2 is a valid solution. All right. Now, if you look at number 16, right, you're probably like, okay, well, these are getting slightly more complicated as we get along. all you have to do with these is if you see multiple logs in one side, is you're going to want to use properties of logs to make it a little bit simpler. So what I'm going to do is I'm going to, with that subtraction, right, hopefully remember from the previous lesson, what does subtraction between two logs mean? Well, it means you're going to divide. So that means I'm going to divide this by 5, right? So then this is going to become log base 6 of 3x plus 14 divided by 5 equals log base 6 of 2x. And then just like the previous problem, we have the exact same log, right? There's a log base 6 and a log base 6, so I can cross out the logs. And then we're left with a linear equation right here. So I get 3x plus 14 over 5 equals 2x. To get rid of the fraction, you can multiply both sides by 5, cross these out, and then you're left with 3x plus 14 equals 10x. And then let's solve for x. So subtract 3x on both sides. And then we get 14 equals 7x. Divide by 7, and then you get x equals 2. All right. Once again, you can check when you plug it in, right? When you plug it in there, you're going to get a positive number, so that works. When you plug it in here, you're going to get a positive number, so it works as well. All right, so x equals 2 is a valid solution. All right, let's try this page now. All right, same exact thing here, right? Nothing special at all, right? I have a log base 2 equals a log base 2, so I'm going to cancel out. All right, and then you're just left with 2x minus 3 equals x plus 4. All right, we can just solve for x very easily. Whoa, I'm kind of jumping ahead there. Hold on. Plus 3 minus x, and then we get x equals 7. All right, once again, check. When you plug it in there, you get a positive number, and when you plug it in there, you also get a positive number, so it does work. All right, let's try this one now. All right, so once again, I see multiple logs. To get rid of multiple logs, you can use properties to condense it. I see a minus, that means I'm going to divide. So this is going to be log of 4x divided by 12 plus x equals log of 2. All right, and then when you don't see a base, you assume it is 10. So they do have the same base, right? So you can simply cross them out. And then we're left with 4x over 12 plus x equals 2. And then you can multiply by this denominator on both sides. So we get 12 plus x on both sides. All right, and then that gets rid of that denominator. And then over here we can distribute, and then so what we're left with is we're left with 4x, right? That's the only thing left over on this side, equals 24 plus 2x. And then we very simply can just subtract 2x on both sides. And then you get 2x equals 12. Divide both sides by 2, and then you get x equals 6. All right, and then once again, when you plug in 6 there and there, you do get positive numbers inside of the logs, so it does work. It is a valid solution. All right. Now let's try some of these, right? You have to do a little bit of manipulation to get the log by itself, right? I only see one singular log here, and it's an ln of x. So let's try to get that by itself. What I'm going to do is I'm going to subtract 5 on both sides, and then you get 2 ln of x equals negative 1. Divide both sides by 2, and then you get ln of x equals negative a half. And then because there's only one log here, it's not going to be a one-to-one property that you would cross out. What you would do is you would change this to log base e of x equals negative a half, and then you would convert it to exponential. So then we get e to the negative a half equals x. And then this is one that you would have to use your calculator to get a decimal approximation. All right. So when you plug this into your calculator, hold on, let me see. Should get you approximately 0.607. All right. Now, if you look, the next one looks very, very similar, so let's do the exact same thing. All right, let's subtract 7 on both sides. We get 3 ln of x equals -2. You would divide both sides by 3, and then you get ln of x equals -2/3. All right, and then just like before, you can turn this into log base e of x equals -2/3, and then you would convert it to exponential. All right, so then you would get x equals e to the -2/3. And then let's do the exact same thing. Let's plug this into your calculator to get an answer, right? And then we should get x is approximately 0.513. All right, so hopefully not too bad so far. I think there's just one more slide. All right, so the next two are going to be pretty similar, right? So 21 and 22. All right, let's give these a try. All right, let's get the log by itself. The log that we're trying to get by itself here is log base 5 of 3x. So let's divide both sides by 2. And then doing that, we're going to get a log base 5 of 3x equals 2. All right, and then there's just one single log here, so we can convert it to exponential. All right, this is going to be 3x equals 5 to the second power. All right, and then this is going to get us 3x equals 25, and then you can divide both sides by 3. Fractions are totally fine in this, so I'm just going to leave it as a fraction, right? No need to plug it into your calculator. All right, and then when you go plug this back in, you do get a valid solution. All right, yeah, plugging into that, x is going to make it positive, right? So it does work. Let's try the exact same thing right here. All right, let's get the log base 4 of 6x by itself. So divide both sides by 3. We get log base 4 of 6x equals 3. And then once again, convert it to exponential. You get 4 to the third equals 6x. And so we get 64 equals 6x. Divide both sides by 6. And then you get x is 64 over 6, and you can simplify this as much as you can. So this is going to get you 32 over 3. Again, fractions are fine. I don't really care if it has a fraction. I just care if it has an e or an ln, all right? But those shouldn't be too bad. All right, these next two can get slightly tricky, but I'll show you how to do them, right? So it's going to be the same thing as we did before, where we try to condense it, right? I see a log, but this time a constant, all right? But we're going to try to condense 2 of these logs to make them a singular log, and that way we can do exactly what we did for previous problems after condensing, right? I see a plus, and if you remember, plus means multiplication, so this is going to be log of 5x times x minus 1. So everything on the inside is being multiplied with each other, equals 2. And then I would just simplify as much as you can on the inside. So this is going to be log of 5x squared minus 5x equals 2. And then once you have this, you can convert it to exponential, right? If you don't see a base, you assume it's 10. So then this is log base 10 of this expression equals 2. And then when you convert it to exponential, you get 10 squared equals 5x squared minus 5x, all right? But 10 squared is 100, all right? So let me go ahead and erase that now, and I'm going to replace it with 100, all right? Notice now that this looks like a quadratic equation. So all we have to do is subtract 100 on both sides and factor it, right? We end up with 5x squared minus 5x minus 100 equals 0. All of these terms have a common factor of 5, so let's divide everything by 5 to make it a little bit easier to factor. All right, we get x squared minus x minus 20 equals 0, and then we should get x minus 5 and x plus 4 equals 0. All right, and the factoring part should be easy, right? We get x equals 5 and x equals -4. All right. The one thing that you want to make sure, though, is that you're checking to make sure that you don't get negatives when you plug it in, right? When you plug in a 5 here and here, you do get positive numbers. However, if you plug in a -4, you get 5 times -4, which is -20. And you're not allowed to have a negative inside of a log. So that means x equals -4 is not an answer, just x equals 5, right? So we only have one answer here, right? So for these, right, typically you always do want to check, but especially when you get two answers, right? Chances are one of them is going to work, the other one isn't. All right, so just something to keep in mind. All right, the next one's very similar, so let's try the exact same thing. All right, this is a property of log. Again, so what I'm going to do is I'm going to take that plus and turn it into a multiplication. This is going to become log of x times x minus 9 equals 1. And then you can distribute that x, and this is going to get us a log of x squared minus 9x equals 1. And then you can do the exact same thing. If you don't see a base, assume it's 10, and then you're going to convert it to exponential. So we get 10 to the first equals x squared minus 9x. But 10 to the first is just 10, so I'm going to erase. All right, it just becomes 10. Now let's subtract 10 on both sides. And then you get this equation. You get x squared minus 9x minus 10 equals 0. And then you're just going to factor this as normal, right? This becomes x minus 10, x plus 1 equals 0. And then we get x equals 10 and x equals -1. All right, so we get these two as our answers, but once again, check. All right, if you plug it into that x and you plug it into that x, right? If you plug in 10, it works, so 10 is a valid answer. When you plug in -1, it does not work, right? It gets you negatives in both of them. So that means x equals -1 is not a valid answer, only x equals 10. All right, but that's about as complex as these examples are going to get. The log equations can be a little bit tricky if you don't know what to do in each type of problem, right? So exponential ones were pretty straightforward. I feel like the logs, again, could get tricky just because there's multiple different approaches that you could take with them. But again, just like anything in this class, keep practicing and it should be okay.